Hi. Welcome back. We are in Lesson 5 of Module 1 of the Python programming course given by Subharaj Academy. Before we proceed, make sure that you have carried out programming as I did in the previous lessons. If not, stop, go back to the previous lessons. You must complete assignment 1.1 before we proceed. We were giving data as part of the program itself so far. This forces the user to rewrite the program with new values when he wants to test the program with new input data. Is this not a cumbersome process? Will it not be interesting if we can give the input through keyboard at runtime when the program is executing? Yes, we can do it and type the input data during program execution. It enables the user to give the values as he desires instead of pre-programmed values. We learn console or keyboard input in this lesson. To find the area of a square, we need the value of the side. We can receive the value of size entered from the console by stating side equals input, enter the value of the side. Quote closing parenthesis. We use the built-in function input to accept a string entered by the user. The function continues to read the string entered till it encounters a newline character. First 3 lines of the program are comments. The user entered value will be received as a string. But we need a numeric value. The built-in function eval is used to evaluate the numeric value of the string. Thus, we use functions input and eval to receive user input. Look at the fourth statement. The value entered is converted to a number and assigned to the variable side. In the next line we calculate area as square of side. In the next line we calculate area. Then in the next line we print string area equals. Finally we print area. The program was executed twice, once with the side, in integer, and then with side, as a real number. Look at the result of the program. Now we will write a program to receive 2 numbers x and y. We wish to find the quotient and remainder. To receive 2 numbers x and y, we have to get the input twice as the program illustrates. Then we find the quotient by integer division. Remainder is obtained through modulus operator, which is percentage sign. Then we print quotient and remainder. Let us now write a program to find the area of a right-angled triangle. We get the values of base and height from the user at one go. The values we receive are assigned to the respective variables as per the order of the variables specified. The area is calculated and printed. We can also receive more than one input at a time by using a function split. We invoke the split function. The split function returns a list. The 4 numbers we are going to enter will be stored as strings in a list. The first num is x, 0, second underscore num is x, 1, third underscore num is x, 3, and the fourth underscore num is x, 4. We convert them to integers by prefix of int to the strings returned by the input and split functions. We know that the input function returns strings. In the previous program we used eval to convert the string to numbers. We can even convert strings to int or float by prefixing the respective types. Here we convert by prefixing int, in other words as int x, o, int x, 1, and so on. While eval converts strings to appropriate number types, the type conversion by prefixing the type like int, float, etc. will convert to the respective types specified by the user. Go back and look at the program. We invoke the split function followed by the input function. The split function returns a list. The 4 numbers we are going to enter will be stored in a list. The first num is x, 0, second underscore num is x, 1, third underscore num is x, 3, and the fourth underscore num is x, 4. We convert them to integers by prefix of int to the strings returned by the input function. In the last 4 statements, we print them. Now we will write a program to receive different data types such as int, float and complex from the keyboard in one statement. Look at the program. Since the second statement spills over to t-line number 3, an escape character is used to continue in the next line. The first number entered was an integer in the form of a string, and hence we convert the first entry into an integer. Similarly, the second entry is converted to float and the third one as complex number. The result of the program confirms our discussion. We received 3 numbers of different types with the aid of split function. Both eval and data types such as int and float are useful in different situations. The eval function converts any string into a number as shown in the slide. But if the number contains leading zeros like 0045, eval won't work, but type specifier like int and float will work. There is a module called random in Python library. Random numbers are the one which changes every time. We can use it to generate random numbers. We can use randint, a, b, function in the module random. The function returns a random integer between a and b, both numbers included. We can also generate a random float r such that 0 less than equals r less than equals 1 using random. Let us write a program. By now you know that the first line is a multi-line or paragraph comment and the second line of the program is a line comment. Then we import module random in the third line. At line 4, we pass random to the print function to print a random float between 0 and 1. At line 5, we generate a random integer between 0 and 9, both inclusive. At line 6, we generate and print random integer between 100 and 200, and in the last line, we generate a random float between 0 and 1. The result of the program may be studied. A byte consists of 8 bits. A bit is a binary digit 1 or 0. We can carry out operations on the bits in the byte using bitwise operators. Some of the bitwise operators and their names are given in the slide. There are 6 operators: AND, OR, complement, exclusive or, which gives an output of 1 only when one of the 2 inputs are 1. We can also shift bits to the left as well as right by specified number of bits. Look at the program. Let us carry out the operations manually before we check with a program. We will take decimal numbers and convert them to binary numbers for manual operations. However, in the program, this process will not be transparent to the user. Let A equals 45, which is 00101101 in binary. Let B equals 89, which is 01011001 in binary. Complement. In complement operations, 0 will become 1 and vice versa. The complement of 00101101 will be 11,010,010. Since the most significant bit, MSB, is 1, this is a negative number. The negative numbers are given in 2's complement notation. To get the actual number, we have to do the following. Omit MSB and find 1's complement of the rest 7 bits. To get 1's complement, subtract 1 from the number. In this process, we will get 1's complement of the number. To get the number, take the complement of above. To get 1's complement, subtracting 1 from other 7 bits, and we get 1,010,001. Let us find 1's complement of this to get the number. The will be 0101110. So this will be 46, and it is a negative number, and so the result is minus 46. OR operation. ORB. The output will be a 1 if at least one of the bits in the numbers is 1. Therefore, the ORB will be 0111101, which will be 125. AND operation. The output will be 1 only when both the inputs are 1. Hence the A and B will be 0001001, which will be 9. The left shift. A is 0010101. Let us shift A by 4 bits to the left. The result will be 00101101000, which will be 720 in decimal. Right shift. Let us do the right shift of A by 2 bit. The result will be 0001011, which will be 11 in decimal. Exclusive OR of A and B. The output will be 1, if either A or B is 1 and not both. A equals 45, which is 0010101 in binary. B equals 89, which is 0101101 in binary. A exclusive ORB is equal to 0111010, which is 116 in decimal. The result of the program confirms our discussion. Python supports graphics, but it is outside the scope of the course. Carry out assignment 1.2 before you proceed to the next lesson. Thank you for watching. That's all for now. Until we meet again, bye-bye.